My name is Ivan. Thank you. My name is Ivan, and I'm a software engineer working on Android Studio at Google. I've been working on the build system, that is the Android Gradle Plugin, for a bit more than 2 years, and today I would like to introduce you with some of the internal things and how stuff that simply works under the hood. This is just the outline of the talk. So I'm going to be talking about different phases of the Android Gradle Plugin lifecycle and what is done in each of those phases. You're going to see how the things that you're changing in your build.gradle files actually get captured, and how these APIs, how we understand them internally. Also, we're going to look at the future APIs, something that we are currently working on, and we are hoping to ship in Android Gradle Plugin 3.3, and hopefully that's going to make you happy if you're using them. And also, we are going to look at the build from the inside, so hopefully you're going to leave this talk with a bit more knowledge about these parts, and whenever a colleague of yours in the company asks you how something works, you're going to be the one that's able to provide the answer. All right, how many of you are using the Android Gradle plugin? Yay, correct talk then. All right, so then I won't describe this a lot. There's a build script. This is how you apply the plugin. This is specifically an application plugin. And then here's the DSL on the right-hand side, where you can specify Android-specific properties such as compile SDK, minimum SDK version, and all the other properties that I'm sure you're well familiar with. All right, I mentioned that I'm going to describe the lifecycle of the plugin. So, but it's important to know that there are two phases that we basically care about, and I'm going to focus on. The first one is the configuration phase. And these are most of all Gradle concepts. After all, the Android Gradle plugin is a plugin that runs inside a Gradle daemon, so it needs to conform to these rules. So in the configuration phase, the tasks are being instantiated, they are configured, dependencies between tasks are established, and in the execution phase, that is actually when the tasks get run, that is actually when the processing is happening. So before we dive into the configuration phase of the Android Gradle plugin, let's just briefly go over some of the basic building blocks that are touched in this phase. So first of these blocks is the DSL, domain specific language. In the previous talk, Alex has built a plugin which he described what the DSL is used for, but in general, it is just to describe the desired output. Basically, if you want to have your bytecode instrumented for test coverage data collection at runtime, then you would specify android.buildtypes.debug.testCoverageEnabled equals true. Well, that was a mouthful, but it basically says that the Jacoco task is going to run, and that Jacoco is going to instrument your bytecode with all the things that are necessary in order to collect this coverage data at runtime. So these DSL properties, so internally we split them into two different categories. The first one is the global one, which is basically, these are the DSL options that are applied to all of the variants. So I'm not sure if you use them, for instance, APT options or DEX options. These are things that are applied to all of the variants, like for instance, compile SDK version. Each of the variants captures those. However, they can be variant specific. So for instance, this one is going to, the one that I mentioned, the test coverage enabled, is just going to enable the test coverage only for the debuggable variants. So here you can see I'm referring to this as variant specific, but in essence it is an entire category of variants. So all of the debuggable variants are going to have Jacoco task running for them, while the non-debuggable ones are not going to have it. So there is no way to clearly specify a single variant that's uniquely identified with all of its build types and all of its product layers. Now I've been talking about a variant, but what is actually a variant? I haven't defined it. Variant basically describes a single output of build, and also it describes all of the intermediate artifacts that are built in order to produce that final artifact. So for instance, if you're building an APK, all of the manifest, classes, DEX files are just intermediates that are being built in order to produce the APK. and the variant uniquely defines those. And different variants produce different output, but also the intermediates might differ as well. By default, you always have two enabled, so there is debug and release. And in general, if you want to figure out how many variants you have in your build file, you take Cartesian product of all of the values for the build types, then all of the values for the dimension 1 of your product flavor, for dimension 2, and so on. So basically, if you have debug and release build types, and you have a single dimension, for instance, price, and first value for that is free version, and second one is paid version, so you're going to have 2 times 2 equals 4 variants in total. All right, now that we know what DSL and variants are, I can introduce another concept that is Variant API. So, how many of you have used the Variant API? Oh, that's more than I hoped. I hope your experience was manageable so far. So that's the current API that's exposed by the plugin. It was designed a while ago, and basically what we wanted to allow developers to do is to examine and modify variant-specific information. So previously we had DSL that's sort of variant-specific, but through this API we actually wanted to allow modifications of a single variant, so just specific variant. For instance, in the previous example, that would be allowing to modify debug paid version, for instance. And in this code example, you can see that with Android.application_variants.all, and then passing disclosure printline it.name, we're basically printing all of the names for all of the variants in our application. Besides printing a name, you can also set some properties for variants through this API, but not all of the properties that you can set through the DSL are reflected through this API. And that is one of the issues of this current API that I'm going to refer to later on. You can also not only change the properties associated with the variants, but you can also add new tasks. So here you can see that you can also specify it.register pre-javac generated bytecode. This basically means that if you would like to add a processing step in which you're producing a bytecode that's supposed to be added to the javac class path, you should use this API to register the task. So for instance, this task, it is used by Kotlin plugin, and this is important because Kotlin files need to be compiled with Kotlin C before javac runs, because simply you could have Java files referring to types declared in KT files. So these compiled Kotlin files that are compiled to class file are simply passed as class path to javac compilation. All right, so knowing all of these bits and pieces, let's try to see how the entire configuration phase looks like. So the moment you say apply plugin Android application is when the extension is created. In our case, that's Android extension. And this extension is necessary to be created in order for the entire configuration to be captured and applied to the objects, to the DSL objects that we have created. So basically this allows, if you try to put the apply plugin Android application after the Android and then the closure part, like at the bottom of the build.gradle file, Gradle will complain because it doesn't know what the definition of Android extension is, right? So it needs to apply the plugin and only then it knows to evaluate the DSL. After the extension has been created, we can create the non-variant specific tasks. So because I mentioned the intermediates of artifacts are uniquely identified with the variant, and depending on the variant, these differ. There are also tasks that are not variant specific. So for instance, we have a task that clears Android build cache, and this task is by no means variant specific. And there's no need to create it for all of the variants and just to duplicate the same task multiple times with different names. So we can just create one that's completely non-variant specific. After this has happened, the DSL is evaluated. So basically the configuration that you have passed to the Android extension is actually captured by the DSL objects that we have created and that we have access to within the plugin. Now this is an interesting moment, because there is a callback provided by Gradle that's after evaluate. So this means that all of the build files have been evaluated, and this is important because we want to make sure that the DSL objects that we have created have captured all of the data that you have entered as users. Once we know that that has happened, and that is when Gradle invokes project.afterEvaluate, and that is actually when our callback runs, we're actually able to create the variants. Now, these variants, they capture all of the data that's entered in the DSL, and from this point onwards, you can think of the DSL object as being obsolete. All of the data that's necessary for a variant is now, in order to build the artifacts, is simply now captured in the variant. You can see that this create a variants block is also creating the Android Gradle Plugin variants, the objects at the bottom of the graph. After this, the second step is creation of variant-specific tasks. Because each variant might be configured in a different way. Like we saw the debug variant might have test coverage enabled, and the release might not have it enabled. For each of the variants, we're going to create tasks, and you can see that the create tasks block is creating these AGP tasks block at the bottom. Now, only at this point is actually when the variant API is able to run. The reason for this is because in the API, we expose both the configuration regarding the variant, so the data about the variant, but we also expose some of its tasks. So we might expose through the variant API packaging task or JavaC task. And in order to expose these objects, we actually need to create them before the variant API runs. And here, you can basically see that the variant API is mutating both the variants and the tasks. And you're going to see why is that an issue. Now, how these callbacks defined by user actually get executed for the variant API, that is basically, we are using the .ol. And .ol is a method defined on the Groovy collection that basically means execute a method on all of the objects of this collection, but also for any object that gets added to this collection, execute that method as well. So basically, you define this method in build.gradle. And then when we create all the variants and when we create all the tasks, when we add these internal objects accessible to application variants that's accessible in the build.gradle is when the callback is being executed. So, knowing all these details, what are the current issues? So, first of all, variants and tasks are mutable. And that creates, for us, quite a bit of confusion internally, and it has caused a number of correctness bugs when we were simply not, we were not reading the properties at the right time, or we would be initializing the task with a property that could later be changed by the variant API. And we would really like to avoid these correctness issues. Also, because the objects that we pass through the variant API are not clearly defined, we are leaking a bunch of implementation details, and these change all the time, and so some users start using some of the private properties or classes with package name that contains internal, but there is simply not, we have not ourselves enforced separation of objects, and which are the part of the API, which are only internal. This is mostly regarding the DSL, but there is no way for you to set all of the properties that you can set through DSL through the variant API. So for instance, the one regarding test coverage enabled, it's impossible to set it through the variant API. And it's impossible to set it through the DSL as well for a specific variant. So what people do, they typically they fetch the task that actually is required, and they disable it, or they completely rewire the task graph, and that creates issues when upgrading your Android Gradle plugin. And last not the least is the documentation on these matters is basically missing. We are very poor. We have done a very poor job with this. However, we have a plan. Basically we have identified the main issues that I mentioned already. We have conflated two things. We have conflated the way to provide you with something to change the variant configuration with providing you a way to hook into the task graph that we are managing. So the API that is currently work in progress, and we're planning to roll it out in 3.3, is basically to provide a way to specify the variant-specific configuration through one part of the API. This part of the API will run when DSL is evaluated, and it will allow you to specify any of the DSL properties through this API. However, this part of the API will not deal in any way with the tasks. Second part of the API regards task creation. And this is for users who would like to add tasks or to replace tasks of the Android Gradle plugin with their own. And this part of the API will run after all the variant-specific information has already been gathered. So let's see each of these two different parts of the API, what it actually does. So for the part of the API that deals with variant creation, it will run on project.afterEvaluate because we still need to capture the DSL. We still need to evaluate it, we still need to capture that in the DSL objects that the plugin manages. So you can think of this part of the configuration phase has basically remained unchanged. After this point in time, the mutable variants are being created. But these are now controlled. We know that they're mutable at this point because we are going to make them immutable later on. But before we make them immutable, we're going to allow modification of any of the properties that a variant exposes. So all of the properties that you can change through DSL, we're going to allow you to specify these through this variant API. But after this API runs, all of the variants are made immutable. So if you try to change a variant property, after this phase, we're going to throw a runtime exception. So basically breaking the build and configuration phase. This is a way better position to be in because the configuration of tasks and actually knowing which tasks need to be created, we now know for sure what needs to be done. Better than being in this middle ground when we're not actually sure whether a task should be created when the variant properties are final. This leads me now to the second part of the API that concerns the task creation. So because variants are immutable, and this part of the API regarding task creation is going to run after the part of the API that deals with the variant modifications, we know that we can create tasks with final fields. Now this might not seem as much, but basically we had to specify tasks, task inputs with delayed evaluation. So we had to use callables, suppliers, and all the other ways to actually delay the evaluation of task inputs, simply because of the way that, simply because the current API it was not designed in a good way. The API that's going to allow this task creation, we call it for now buildable artifacts. We'll see the name remains, but it's going to allow basically adding a task that produces additional files for a specific artifact type. So let's go back to the Kotlin plugin example, where basically Kotlin task in this scenario is not going to invoke the variant API method, it.preregister JavaC bytecode, yada yada. It's going to basically say, here's a task that appends to already predefined artifact type. And we're going to wire everything together. If for some reason someone wants to replace a task that we define, that's also going to be possible through this API. And after this API runs, the internal representation that we have that regards task dependencies is made immutable. So any changes to that are not going to be reflected in the task graph, but that allows us to set up the task graph correctly. After this phase, and this part of the API has run, the execution phase is next. But let's just quickly see why did we opt into doing the buildable artifacts. Why do we think that's the right way to go? When thinking about artifacts, we prefer to think about them as just having a type of an artifact. So I care about JavaC classes. I don't care who produces them or how. Or if you want to get a manifest, you only care about the manifest. You don't care that the manifest merger produces that, or that the manifest merger has a ton of other dependencies, right? So with buildable artifacts, we have basically put the type of an artifact that's produced as the first-class citizen. And this allows us to simply have a new task that just produces new artifacts and that register itself with this artifact type. So with Kotlin, we are just going to say Kotlin contributes to these JavaC classes, and here's a task that produces them. But this information, this dependency information, is embedded within the artifact. Also, we're going to allow replacing existing tasks if someone wants to do that. So we saw how the previous graph looks like at the configuration phase, but basically there aren't many changes. The bottom part is slightly altered. After the variants are being created, the API that allows modifications of variants is run, and at that point the variants block remains starts being immutable. After that, we create all the tasks, and the Buildable Artifacts API runs, and from that point onwards, the tasks are made immutable. Okay, so that was part that concerned the APIs. But now let's just see what are the actually tasks in the context of the Android Gradle plugin. So typically a task is just a single task. We try to make it a well-defined, incremental when possible, and cacheable unit of work. This is mostly to improve the build speed. Typically inputs for file collection are file collection, and callables for inputs that are modifiable by the Variant API that I mentioned. If you want to see all of the tasks in your project, you just need to run Gradle W, project name, and then tasks. That is a task that actually prints all of the tasks in your project. So, for Android Gradle plugin, how many tasks are there? Well, there are almost 100. We have contributed to this number over a period of time. When the number was way less, we used to rely on task.depends_on API. You don't need to know what this actually does, but basically this is manual wiring of tasks. It's saying that task A depends on task B. And also we would specify inputs of tasks as files. Now this is very error prone, and adding new tasks and features was very hard, and refactorings would always introduce some bugs. So alternative approach that we have taken was to combine both the artifact location, that is the actual file, and the dependency information. And fortunately for us, Gradle already has such an abstraction, and that's the file collection. So that was sort of task in isolation, but how do they communicate? How do they wire together? So there are two types of artifacts we care about. There are the artifacts that come from the same project, but there are artifacts that come from other projects and external dependencies. So within the project, how do we manage these artifacts? The task that actually produces a specific artifact type, it registers itself with the variant. So a JavaC task, for instance, would register itself with the internal artifact type.javac, and would point to a folder that contains all of the compiled JavaC classes. Now you can think that each of the tasks that we create does this with the variant. And this is a much easier position to be in, because an artifact is typically produced only once. And all of the consumers, there might be many of them for a single artifact type, they can simply refer to the artifact using the type, and they're going to be given a file something similar to file collection that contains all the dependency information and also the location of these files to be fetched from the file system. But how do we deal with external dependencies? For these, what we do is we try to use artifact transforms when possible, and this is something that's provided by Gradle. So artifact transforms allow you to describe a pipeline in terms of simple transforms that transform an input to output in predefined format. So you're able to register a transform that might transfer an AAR to an exploded AAR, which is basically unzipped AAR. And you can also register a transform that goes from an exploded AAR to manifest. Now, if you provide Gradle with AAR, it's going to know to set up the correct pipeline of transforms to produce you with the manifest, if that's what you ask for. We have opted to use these quite a lot when possible, because these are cacheable units of work, so no need to rerun them once they have been cached. and also these can, because they are well isolated, they can be run in parallel. But here's the interesting part. How do we deal with inter-project dependencies? Basically, every project exposes a set of artifacts that they're able to build. And ideally, we would like to avoid building an entire project just to get a single artifact. So if an application depends on library, we would like to avoid building, to basically executing assemble on the library project. We would also like to avoid building all the different versions of some artifacts. So we would like to avoid building both debug and release Android manifest.xml of a library if we need only the debug one. So ideally, we would like to build, to run only a single task that builds the artifact that we actually need, and of course all the tasks that this task depend on. So in order for projects to publish the artifacts, to advertise what kind of artifacts they are able to build, projects publish artifacts to multiple configurations, and these configurations are consumable by the projects that depend on this, for instance, library project. These configurations are published per variant, and when tasks is instantiated and when it registers itself with the variant, we piggyback on this mechanism to figure out whether this artifact is something that this project needs to publish. So for a library project, there are many intermediate artifacts that we do not actually want to expose to the application project, but for the ones that we actually want to expose, this mechanism in which we register the task to the variant, the variant just publishes these artifacts externally. So here you can see an example, like if we have my library, which is a library project, and it publishes actually 4 different configurations. So it publishes debug runtime elements, release runtime elements, and debug API elements and release API elements. So basically there are 2 configurations, runtime elements and API elements, but they are published per variant. On the other hand, if we have an application project, and in its build.gradle file, this application project contains compiled project my library, this means that through this dependency, this application project gets access to all of the artifacts that are published to all of these configurations. So, how do we know to which configuration the artifact needs to be added, and how do we associate data with the artifact? So variant, once it receives the call to register the task that produces certain artifacts and with certain artifact type, it knows how to map this internal type to external one, if such mapping exists. So, internal artifact type.library manifest, variant knows that it should map this type to artifact type.manifest. And through artifact type.manifest, application is able to query for this artifact type, because artifact type.manifest is something that's publishable by the projects that we create. The way that this is done on the publishing side, so on the library project, is through configuration.getOutgoing.variants API. Now, I have put 3 dots here in the variants, but basically here you specify the information about artifact type, but you also can associate the task that actually builds this artifact. So if someone depends on this artifact, it also gets the dependency information. Now on the consuming get for the application project that depends on this library, you can fetch artifacts by specifying configuration.getIncoming.variant artifact view.get artifacts. In the artifact view, you can actually specify the artifact type. So in this case, we would specify artifact type.manifest, and we would receive this artifact with all the dependency information that's necessary to fetch that. So another task that depends specifically on this artifact knows that it has to run a task in a different project in order for this artifact to be built. However, I have used here only artifact type.manifest to describe an artifact, but that is not enough to uniquely identify the artifact. Remember, there could be multiple variants that are building this Android manifest. So we could have both debug and release version of the Android manifest. So which one do we pick? How do we know whether we should build a debug version of the Android manifest from a library project or the release one? So in order to solve this issue, we are basically using attribute matching strategies that are provided by Gradle. This allows us that on the publishing end, when specifying the artifact type and the task dependency information, we also specify the build type of the variant that's building that artifact, and we also specify one or more product flavors for that variant. We also specify some additional metadata part for the illustration purposes that does not matter. Now, on the consumer end, when we would like to fetch an artifact, that artifact is fetched in a context of a specific variant. And while we know that the artifact type is artifact type.manifest, we also know what is the build type and product flavor of the consuming variant. And what we do here is we try to find a full match between all of these attributes, and once the match occurs, then we know that that is the artifact that we actually would like to depend on in the application project. I hope it makes sense. It took me a while to figure this out. So after this pretty deep dive in the plugin, I'd like just to leave you with a few advices. In case you're writing a plugin, but not only a plugin, if you have any piece of logic in your Buildable Gradle file that's using this Variant API, please do not depend on internals. They change quite a lot. Also, these internals are, they're completely our own fault for exposing them, but there's so much information there. I know it might be tempting to reach into them, but we do break you, and that's sad, but that's why we're trying to work on these new APIs that should reduce the number of breakages. Also, please do not depend on task by name. Although some tasks seem that it has been there forever, we do change them, and in some new configurations that we are introducing, some of the tasks might be actually missing because we are adding new tasks with different name. And so this breaks quite a few plugins. Also, currently we are in canaries of 3.2. When canaries of 3.3 start coming out, please try them out and please provide feedback. When designing these new APIs, we tried to look at all the different use cases, and we tried to cater for all of them, but I'm sure we missed a few. So please do file bugs. We'd love to take care of all of the use cases. And last but not the least, please follow Gradle's best practices. Try to make your tasks to run incrementally when possible, and also try to make them cacheable when possible. Thanks. If there are any questions, I'd be happy to take them now.
I'm wondering if using the Android Gradle plugin, I could generate a manifest at build time. Instead of having XML that is not so checked at compile time, writing, let's say, a Kotlin DSL that will describe what I want to declare, and then I would make my plugin check if there are any non-abstract activities that are not declared in the manifest, and all other checks that I usually do by hand by looking about the hundreds of lines of my manifest. Is there any possibility to do this with Gradle plugins? That's my question.
Right now, right now you could probably do that, but it would be in a very, very hacky way. So I'm not sure how stable that would be. With the new API, yeah, I think you should be able to do that with the new API, because manifest is just going to be another artifact type that we generate. So in theory, you could just create a task that contains all the logic that you need in order to generate this manifest, and simply publish that manifest as the one that we should package in the APK later on.
Okay, so I will save time waiting for canary driven .3, right?
Yeah, thanks.
Thank you.
Hey, thanks for the talk. I had a question, maybe a curiosity question is what language do you use to write the plugin? Is it Groovy, Java, or Kotlin? And a more general one is, can we one day expect to write Gradle files in Kotlin?
So to answer the first one, a big part of the plugin used to be in Groovy. We have migrated all of the parts to Java because we have figured out that using Groovy had a significant performance cost in our use case. Right now, all the new code that we are adding is pretty much Kotlin. Unless there are any concerns that Kotlin could be in introducing some performance bottlenecks, we simply use it. For tests, we definitely use Kotlin now. And
the last part was, can we expect to write Gradle files in Kotlin? Because every time it's a different paradigm to learn, and it's always hard to switch between Groovy and Kotlin.
Yeah, I agree. I think that's something we would definitely want to do in the future. We are definitely waiting for Kotlin DSL to hit 1.0. Once that is in, there are some changes that are required on our end to make that usable in Android Studio. But simply having better autocomplete and a typed language in which you can write your build scripts, yeah, we would like to be in that position, definitely.
Awesome.
Yeah.
Hello, thank you for your presentation. I had a question about different variants. You said that by default we have debug and release. If, for example, we have many other variants, can we avoid a variant for an app? If our app contains many modules and we want to avoid, for example, the debug, can we do that, and how?
Great question. That's actually part of the API I did not mention here, and I mean it's related to the variant API. There is a variant filter, so you're able to filter out the variants that you do not want to build. So typically this is like on the CI server. If you don't want to completely build the data for some of the variants, you can specify them there. So I think you should be able to find information on the Android developers website how to disable building for some of the variants. You can simply filter them out.
Okay, thank you.
Any more questions? No? Cool, I guess that's it for today. Thank you very much.